In problem number 13, assume that the equation a equals negative 0.125x squared plus 2x plus 1.125 models the attendance at a recently released movie for X weeks. During what week will the movie attain its highest attendance? So I have written our quadratic equation here on the separate sheet, and we're wanting to find the week when the movie will have its highest attendance. In other words, we want to find the highest point on the graph of this equation. Well, notice that this is a quadratic equation, and for this quadratic equation, a equals negative 0.125, b equals 2, and c equals 1.125. Well, the fact that a is negative means this parabola is going to open down. So our parabola is going to be like this when we graph it. And so we have a maximum point right here. Okay? And so that maximum point is going to occur at the vertex. So if we find the vertex, that will give us the week when the movie gets its highest attendance. Okay? So really, we don't even have to find the whole vertex. We just have to find the x-coordinate of the vertex, and that will do it for us. Okay? So the x-coordinate of the vertex, remember, is given by x equals negative b over 2a. So in this case, that's going to be negative 2, because b is 2, over 2 times negative 0.125, because a is negative 0.125. So we're going to get negative 2 over 2 times negative 0.125 is negative 0.250. And negative divided by negative is going to be positive. 2 divided by 0.250 is 8. Okay? So this is the week. So in week 8, that will be when the movie gets its highest attendance. So the answer to the question, week 8. Now we could substitute 8 back into the equation for x to see what the attendance is, but we weren't really asked to find that, so we don't need to do that. Okay, so the answer to number 13, week 8. Let's look at number 14. Number 14. If $10,000 is placed in an investment paying 4.8% yearly interest compounded annually, how much will be in the account after 5 years? So this is a compounded interest problem. In this, we know that the amount originally invested, which is P, the principal, is $10,000. The interest rate, the annual interest rate, is 4.8%, which as a decimal is 0.048. And we were leaving the money in the account for 5 years. And again, we know we're compounding annually. So our formula is going to be A equals P for the principal times 1 plus R for the rate raised to the t power. So all I really need to do is substitute these values in our compound interest formula here when we have compounding annually. So that's going to equal 10,000 times 1 plus 0.048, our rate in decimal form, raised to the 5th power. Now 1 plus 0.048 in the parentheses is 1.048. So I have 10,000 times 1.048 raised to the 5th power. Now if we take 1.048 and raise that to the 5th power, let me use my calculator here, 1.048 raised to the 5th power, that is 1.2641172717. So I have 10,000 times 1.264172717. And if I take that times 10,000, that is 12,641.73 if I round to 2 places. So after 5 years, we'll have $12,641.73 in our account. Let's take a look at number 15. So number 15, how long will it take for the account in problem number 13? Actually, that's an error here. That should be in problem number 14 to double. Okay? So I'm going to just continue number 15 here on the same sheet where I worked number 14. Again, we want to know how long is it going to take to double. Okay? So if it's going to double, then that means the $10,000 will be $20,000 after it's doubled. Okay, so in 5 years, the $10,000 had grown to $12,641.73. We want to know how long until it reaches double, or $20,000. Okay, so I want the amount to be $20,000. My principal is $10,000, and 1 plus my rate, 0.048, raised to what number of years would it take to get this to be 20,000? So I have the equation 20,000 equals 10,000 times 1.048 raised to the t power. And I need to solve for t. So to solve for t, I'm going to start by dividing both sides by 10,000. 20,000 divided by 10,000 is 2. So I have 2 equals 1.048 raised to the t power. Now to solve for t, I need to get that t down from being an exponent. And remember, the way we do that is by using logarithms. So I'm going to take the log of 2, and that is going to equal the log of 1.048 raised to the t power. And then our property of logs allows us to bring that power t down in front. So I have the log of 2 equals t times the log of 1.048. Now, log of 2 is just a weird number. Log of 1.048 is just another weird number. So I have a weird number equals t times this other weird number. So if I divide both sides by this weird number, log of 1.048, that will give me the result. So on the right-hand side, t is going to equal whatever the log of 2 is divided by whatever the log of 1.048 is. Okay? So if we do this again on the calculator, let me pull that in a little farther so you can see it. I'm going to take the log of 2 divided by the log of 1.048, and when I do that, I get 14.7844. So if I round to the 10th place, that's going to be about 14.8 years. So this is about 14.8 years. So it's going to take about 14.8 years for my original investment of $10,000 to double to be $20,000. Let's move on to number 16. Number 16. Assume that a population is growing initially at a 3% rate and that we are using a logistic model to describe the population growth. If P of 3 is equal to 0.50, what is P of 4? So for number 15, or number 16 I should say, we're using the logistic growth model. And the logistic growth model is P of n plus 1 equals 1 plus r times parentheses 1 minus P of n all times P of n. So this is our logistic growth model. Now in problem number 16, we're told that our initial growth rate is equal to 3%, which would be 0.03. Okay? We're also told that P of 3 is equal to 0.50, and we're supposed to find P of 4. Okay? Well, P of 4 is going to equal 1 plus the rate times 1 minus P of 3 all times P of 3. Okay? So that's what this formula means, right? If this is n plus 1, then this is going to be just n. So like if this is 3 here, then this is going to be 4 here. If this was 5 here, then this would be 6 here, and so on, okay? So I just need to plug my values in to figure out P of 4. So that's going to equal 1 plus 0.03 times 1 minus 0.50, and all of that gets multiplied by 0.50. So that's times that, okay? So this now is just an order of operations problem. So I'm going to start inside the brackets and work my way out. So 1 minus 0.50 is 0.50. So I have 1 plus 0.03 times 0.50, again because 1 minus 0.50 is 0.50, and then that's times 0.50 again here, okay? So inside the brackets, I got to do the multiplication. 0.03 times 0.50 is going to be 0.015. So I have 1 plus 0.015, and 1 plus 0.015 is 1.015, and that still times the 0.50. And if I take 1.015 times 0.50, that is 0.5075. So if P of 3 equals 0.50, then P of 4 is going to equal 0.5075. Let's look at number 17. Number 17, assume that a room at a hotel in Disney World costs $220 a night in the year 2011. And that same room, due only to inflation, costs $280 a night in 2015. Use an exponential model to estimate the cost of that room in the year 2019. Okay? So in problem number 17, we know that in 2011, the cost of the room was $220 a night. And in 2015, we know the cost of the room was $280 per night. And we're supposed to use an exponential growth model to estimate the cost of the room in the year 2019. Well, our exponential growth model is that A equals P times 1 plus R raised to the T power. Okay? Now here's how this is going to work. Okay? So if in the year 2011, if we call that year 0, then the year 2015 would be year 4. Okay? We know that 2020 is the initial amount, so that's going to be the P. And then this 280 is the amount, the A, after T equals 4 years. So in other words, I can say 280 is equal to 220 times 1 plus the rate raised to the 4th power. Okay? And so this is going to allow me to figure out what the growth rate is, and then I'll be able to use that along with the rest to figure out what would be the cost of the room in the year 2019. So our real question is, in 2019, what would be the cost of the room after inflation? Okay? So to solve this, to get the growth rate, I'm going to start by dividing both sides by 220. So on the right-hand side, I'm going to have 1 plus R raised to the 4th power. And if I take 220, or 280 rather, divided by 220, that is 1.272727 if I round to 6 places. Okay? Really, the 2 sevens just keep repeating. Okay? So I need to solve for R. To solve for R, I need to get rid of that 4th power. So I can do that by taking the 4th root of both sides. So on the right-hand side, the 4th root of 1 plus R to the 4th power will just be 1 plus R. On the left-hand side, I need to figure out what's the 4th root of 1.272727. Well, remember, we've learned that the 4th root of this is the same as this raised to the 1/4 power, And so that's what I'm going to do on my calculator. I'm going to take 1.272727 and raise that to the 1/4 power. And so that is about 1.062145. 1.062145 equals 1 plus r. Subtract 1 from both sides, so r equals 0.06215. So there is our growth rate. Okay? So in other words, if P is 220 and if R we just figured out is 0.062145, then I have that A equals 220 times 1 plus 0.06215 raised to the t power. And 1 plus 0.06215 is 1.06215. So we have A equals 220 times 1.06215. That's our model. Okay? So we can use that to figure out the answer to the question. Now, if 2011 is year 0, 2015 is the year 4, 2019 is going to be the year 8. So all I have to do is substitute 8 for t. So I'm going to have 220 times 1.06215 raised to the 8th power. So bring in my calculator again. 220 times 1.06215 raised to the 8th power. So that is about $356 if I round to the nearest dollar. So in the year 2019, the room is going to cost about $356 per night. Let's look on to number 18. Number 18, we want to solve the following proportions. Okay, so we have two different proportions that we want to solve. We'll do that again on a separate sheet. So if I bring in number 18, we have part A and we have part B. So part A, I'm going to rewrite it. We have the ratio 25 to 8 equals the ratio of x to 2. So this is a proportion, but I'm going to write that in fraction form. 25 over 8 equals x over 2. So to solve a proportion, we can cross multiply. So I'm going to take x times 8, which would be 8x. 25 times 2 is 50. And so to solve, we divide both sides by 8. And so x equals 50 divided by 8. And 50 divided by 8, we could either reduce that. We can divide 50 and 8 both by 2, which would give us 25/4. So if we wanted to write our answer as a fraction, we could say 25/4. Or if we want to write it as a decimal, 25 divided by 4 would be 6.25. Okay? So x equals 25/4 or 6.25. Okay? Here we already have our proportion written in fraction form, so we're going to do the same kind of thing. X times 4 is 4x. 30 times 5 is 150, so 4x equals 150. If we divide both sides by 4, then x is going to equal, again, I can leave this in fraction form and reduce. 150 divided by 2 would be 75. 4 divided by 2 would be 2, so that would be 75 halves. Or if we want to put that in decimal form, that would be 37.5. Okay? So for part A, x is either 25 over 4 or 6.25. In part B, x is 75 halves or 37.5. Now let's look at problems 19 through 23 on one last video.